Good morning and welcome to my YouTube channel, Pearson Edexcel International Maths by Mr. Kamotho, and we continue to explain Pure Mathematics 3 IAL, and we are in topic number 6, and I want us to go direct to example number 4. Before we go to example number 4, we have to understand something to do with differentiating exponentials and logarithms. That is the topic today. And up there on page 128, you need to be able to differentiate expressions involving exponentials and logarithms. And we are told if y is equals to e raised to power kx, then dy dx is equals to k e raised to power kx. That is a very important piece of information. And we also told this is number 1. There is another statement that we need to understand. If y is equals to natural logarithm of x, or rather ln x, then dy dx is equals to 1 over x. Eventually, we shall be able to see what this means. And I want us to straight go to example 4, and prove the first statement there using an example. And we are told to show that the derivative of a raised to power x is a raised to power x ln a, and that's just where we start. In other words, if we are talking about if y is equals to a raised to power x, then dy dx is equals to a raised to power x ln a. This is what we are supposed to prove. Fine. So we are saying in the very first statement, let y be a raised to power x. And of course, if we know this is what we have. And because we have ln, then we will have to introduce log to base e of anything. So introducing log to base e of all this, we are going to have log to base e of y is equals to log to base e of a raised to power x. And if we can probably rearrange this without changing the meaning, we are going to say log to base e of y is equals to ln, because ln is simply log to base e ln a raised to x. And that is just what we have. And this is in logarithmic notation. And we have talked about, if we know that the log to base 10 of 100 is equals to 2, according to anticlockwise movement, this takes us to the index notation, which tells us 10 squared is equals to 100, and that is very correct. So as much as we would want now to use this logarithm and ln ax as a constant, then we can say you can apply the anticlockwise movement there and have it like e raised to power ln ax. We are going to have e raised to power ln a raised to power x is equals to y. In other words, this one is giving us something to do with e raised to power x ln a is equals to y. And we have something like that. So at that point, it's already in terms of, or rather, let us compare this with something that we know. Y is equals to e raised to power x ln a. X becomes a coefficient of the ln because it was already in the index position. And I would want just to explain that. I would want just to explain that here and say ln a raised to power x is the same as log to base e of a raised to power x. And this is the same as x log to base e of a, which is x ln a. And this one is very clear in the laws of logarithms. Everybody should note that. So y is equals to e raised to power x ln a. This one is already in the form of y is equals to e raised to power kx, where k now happens to be the ln a. If this is true, then we know dy dx according to this, should give us k e raised to power kx. In the same kind of way, if y is equals to e raised to power x ln a, then this one gives us dy dx is supposed to be equals to ln a, because ln a now happens to be k, e raised to power x ln a. But I want us to concentrate on, because now we have had our k, I want us to concentrate on that part, because we can rewrite it in terms of ln a e raised to power ln a raised to power x. And if you want to revisit that part, it's going to be y, but this is just y. You can see, I want us to look at this e raised to power ln ax or e raised to power x ln, which is simply y. But originally, what was y? Originally, y was equals to a raised to power x. So this is, if you look at this, this is going to be ln a multiplied by y, because if you compare that with what we have here, it is going to be ln a multiplied by y. Now, but y is equals to originally a raised to power x, and therefore the dy dx, but y is equals to a raised to power x, and therefore the dy dx is going to be ln a y, which is a raised to power x. You just have to rearrange this so that the ln does not seem to affect a raised to power x. This is ax ln a, and that is just what we are supposed to show, and it has been proven that the derivative of a raised to power x is ax ln a. Please follow and make sure you understand all the steps. Again, visit my YouTube channel, Pearson and Excel International Math by Mr. Kamotho. Subscribe, of course, share widely and like. All right.